This is a short video on right triangle trigonometry. Given the triangle below, we want to find all three trig functions for angle A. So we're looking at this angle down in here. And before we can do that, we should try to find all sides of the right triangle. Right now we know that we have a side 5 and a side 8, and we have the hypotenuse, which we still have to find. To find the hypotenuse, we're going to use the Pythagorean theorem. So I'll just call this x for now. And we know that by the Pythagorean theorem, that if we say 8 squared plus 5 squared, that should equal x squared. Once you have that, 8 squared is 64, plus 5 squared is 25, should be equal to x squared. 64 plus 25 is 89, equals to x squared. And then taking the square root of each side, we'll be left with x is equal to the square root of 89. So we know the length of the hypotenuse here is the square root of 89. Now we want to use this to help us find the trig functions for angle A. And if I was looking for the sine of angle A, we know that's supposed to be the opposite side over the hypotenuse. Alright, and so we're just going to substitute in. So the sine of A should be equal to the side opposite A, which is 8, right, looking straight across here, it's 8, over the hypotenuse, which we just found was the square root of 89. Because we have this in terms of a radical in the denominator, we have to rationalize the denominator. And the way you do that is by multiplying both the numerator and denominator by whatever was in the square root. So the square root of 89 on the bottom, multiplied by the square root of 89 on the top. So this will equal 8 square root of 89 all over 89, because square root of something times itself is just whatever's inside. So that would be the sine of A. If we're looking for the cosine of A, we do something similar, except for now cosine is adjacent over hypotenuse. And if we want the adjacent over hypotenuse, here's angle A, so we're starting at A, the side next to it is what adjacent means, so the side next to it would be 5 over the hypotenuse, which is the square root of 89. And again we have to rationalize by multiplying by the square root of 89. Multiply by the square root of 89. This gives us 5 square root 89 all over 89. So that would be the cosine of A. And then lastly, the tangent of A is equal to the opposite side over the adjacent. So here's angle A, the side opposite would be 8 over the side adjacent would be 5, and since there is no square root in the denominator, that's going to be our answer there. This is just another video using right triangle trigonometry to solve a right triangle. The first thing you should do here is in this triangle they're asking us to find two of the sides and one angle that's missing. They already gave us they actually gave us two angles. They gave us that it's a right triangle, so we know that that angle is 90 degrees and angle A is 24 degrees. They also gave us side B, which has a length of 12. The first thing you should do is make sure your calculator is in degree mode. If your calculator is not in degree mode, this won't work out correctly. In order to find one of the sides here, or actually we can start with finding angle B. Angle B should be equal to 180 degrees, because that's the sum of the angles of a triangle, minus the 24 degrees minus the 90 degrees. Just subtracting off angle A and the right angle, we can find angle B, and that'll be 180 minus 24 minus 90, which gives us 66 degrees. So angle B we know right now is 66 degrees. You can fill that in up here, or you can just have it written down here. So angle B is 66 degrees, and now we want to use some of the information about the angles and the relationships to the sides based on our trig functions sine, cosine, and tangent. We'll use angle A here. If I wanted to find just side C, let's say, we know the adjacent side to A is 12, and side C, the hypotenuse, is what we're looking for. So if I was using the cosine of A, that's equal to the adjacent side over the hypotenuse, which is C here. Well, A we know is 24 degrees, so we're really saying the cosine of 24 degrees is equal to 12 over C. Realize that I'm using cosine here because I need to only have one unknown side. If I was to use the sine of A, that would be opposite over hypotenuse, and we'd have A over C. You wouldn't be able to solve for either of them because there'd be two unknowns in the equation. So I'm using cosine because that only creates one unknown. The adjacent side is known, alright, the hypotenuse is unknown. To solve this, we're just going to cross multiply, and you get C times the cosine of 24 degrees is equal to 12, and we'll divide both sides by cosine 24 degrees. Divide by cosine 24 degrees. And we'll evaluate this. You're going to have 12 divided by cosine of 24 degrees, which comes out to 0.914. And so C is approximately, if I do 12 divided by the 0.914, that comes to 13.1. So we know the length of side C is about 13.1. Similarly, we can find side A. If we use, now we know the hypotenuse, so now I can use the sine function. So I'll say the sine of A, right, that's always equal to the opposite side over the hypotenuse. So here it would be the sine of 24 degrees is equal to the opposite side, which is A over the hypotenuse, which is 13.1, and again we can cross multiply, and we'll get A is equal to 13.1 times the sine of 24 degrees. So A is equal to, if I multiply that out, 13.1 times the sine of 24, that should come to 5.32. And that would be the length of side A. You could also do these using angle B, except for the relationships would be a little different because, you know, the sine of B and the cosine of B would be relating to the angle up top here instead of the angle down here. I hope this video is helpful and helps you further understand trig.